Hello students, today we are in lecture number 7 of the same chapter 1 of electrostat. This is B.S Pandey. Student today will try to solve few questions of Coulomb's law. As I told you in last lecture, we'll solve few questions on the basis of Coulomb's law. Okay, so the first simple question: if you are having a charged rod on which charge is uniformly distributed, suppose this charge Q is uniformly distributed on the length L, okay, and another charge, small q, is placed at a distance, suppose it is A, and you have to find the electrostatic force between this rod and this charge. Length of this rod is L, okay, this is the length of the rod. So how will you solve this question? Same type of question you have been solving gravitation also. While teaching gravitation, I have told that recall such type of question and try to memorize, because the same types of question will be repeated in electrostat in standard 12th. Now today we are in that class we were talking about. Okay, now students, to find the force between this rod and this charge, as we know that the Coulomb's law is applicable for 2 point charges. Here this Q is point charge, no doubt, positive point charge, but this rod is not the point charge. Here the charge is uniformly distributed over the length of the rod. So first we will try to find out the elemental section of this rod. Elemental section of this rod. How we will find the elemental section of this rod? We will take a elementary length as dx, okay, at a distance x from this charge q. Now we have, and the charge of this elemental length will be dq. Suppose it is dq. Now we are having 2 point charges. One, it is dq, and another it is q. These two charges are separated by now a distance x. Now we can write the force. Since this charge is very small, so the force will be on this charge, force will be small. Since these two are positive, the force will be in this direction, and we can write here the df. We can write using Coulomb's law, df equals to k q1 q2 divided by separation square, it is x square. Now we don't have the value of dq, so try to find out dq by unitary method. Okay, if on L length charge is q, so my dear students, using unitary method, you can write on unit length charge will be q by L, but we have to find charge on which length? On dx length, which is the elemental length of the conductor. So charge on dx length will be q by L into dx, and this q by L into dx is nothing but a small charge dq. Now this q by L is also considered as the unit length charge, that is the linear charge density. It can be represented as lambda dx. Kindly note down. Now students, you will put the value of this dq in this equation, and then you will have this equation. You will integrate this value from here, that is a to a plus L, to get the answer. And at A the force will be 0, and the force will be maximum F at the total length A plus L. Okay student, so this is your equation after putting the value, that is KQQ by L, and this integration of 1 by x square will be minus 1 by x, you know, and it will be integrated with the proper limit a to a plus L. Now you will have the answer. Now students, you can write F equals to KQQ by L under bracket after putting the proper limits, student. Okay, and then F will be KQQ by L and then proper value. Now you can solve this question further by taking proper LCM. Okay, but you will get the answer in the different book in same way. After simplification you can write the answer. Now if you will be asked the same question to solve, such a question will be asked in competition, as I told you, the same question to find the force between this rod and small element, small charge. It is positive charge uniformly distributed over the length L, and from center, okay, from center, that is L by 2 and L by 2. Again the charge Q is placed at a distance A. Now you have to find the force on this charge Q. Find force on charge Q due to this rod. Okay, then how you will solve this question? Students, I'm giving you a very simple hint to solve this question. You will take elemental section above the rod. For simplicity, you will take another elemental section over here, and then you will integrate this rod from 0 to L by 2. Or if you are taking only one elemental section, then there will be two component of the force in along the x-axis and along the y-axis. If you have been cut out over here the elemental section, what will be happen? There will be force between this elemental part and this positive charge. This positive charge will move along the line joining this elemental section and this Q, and it will move in this direction. So this force will have the two component along x-axis and along y-axis. So why I'm telling you to take another elemental section over here? As you will take the elemental section over here, it will have two component again, one along x-axis and along y-axis. Since the same elemental part you have been taken, the two component over y-axis will cancel out, and you will have to now solve only for the two component along the x-axis. So if you are taking the two component, remember you have to integrate from 0 to L by 2. If you are taking the only one elemental section, then you have to integrate for the whole rod. That is, if this is your origin, because you have been represented the force from here and this is the origin, then the integration will be from minus L by 2 to plus L by 2. In this way you can solve this question. There will be some lengthy integration, okay, and you have been already studied in your standard 11th. I'm not talking about that integration you have been solved in standard 11th mathematics, but in physics you have been solved such type of integration in gravitation chapter, students. So try to solve this type of question by yourself. Another question in competition you will be asked, student, like this one. Suppose you have a charged ring. This is the ring, okay, and positive charge uniformly distributed over the ring. This is the ring in this way, and positive charge uniformly distributed over the ring. Okay, now from the center a charge is placed from the center. Here a charge is placed at certain distance, say it is A. At from center O, a charge is placed at a distance A. This charge is positive Q, and thus total charge distributed over the circumference of the ring, it is capital Q, and small q is placed at a distance A. If this ring is fixed, as this rod was fixed, this ring is fixed, then you have to find the force on this small charge. Of course, this charge will repel and it will move away. You have to find the force on this charge. Again, student, I am giving you the hint to solve this type of question, and this type of question will discuss in our classroom program. So I am giving you only hint over here. You will take again elemental section of this ring. First, you will try to find out. Here I am giving you the radius of the ring. It is R. This is given. Okay. What are given? Charge on ring. It is plus Q given. This small charge which is placed at a distance A, it is given. A is given. This charge is given, and radius of the ring, it is given, and nothing else. Okay. This quantities are given, and you have to find force on charge Q. Okay, plus Q. So you have to find the charge on this plus Q. So you will take the elemental section over here and over here and try to find out the force on this small charge Q. Now, while solving this question, student, you will generalize the answer and you will just play with the answer. Okay, student, you just play with the answer. What will happen? Then what will be the force? Question, you will change. All the conditions are same. Now you will change a very certain condition. What is that? It is if this charge is placed at the center O, that is A tends to be 0, then find force. Okay, find force. Now you can change this question again. In this case, again you are having the ring. Now the ring is positively charged, and minus Q is placed at the same distance, same radius, everything are same. Okay, now what will be the force? And again the next case, if A will be 0, that this charge goes to the center O, then what will be the force? Now the interesting fact behind this question, student, that you might be faced few question of such type of question in competition to find the time period. How, student? So listen carefully. I am just formulating or just changing this question with a very small condition, and you will see how you can solve this question to find the time period. Suppose a student, if this ring is charged with the positive, okay, a positive charge, okay, a positive charge is placed at center. Of course, at this point F net will be, this is the example, F net will be how much? F net will be 0. F net will be 0. Now what will happen? At the center, charge is placed and it experiencing net force 0. If you will displace the charge by the small amount, what will happen? It will experience a repulsive force, because this is positive and this is also positive. It will experience repulsive force, okay, and it will move away. But here it will be the repulsive force and it will not regain or come back to the center again. So this is in unstable equilibrium. But if the condition is such a way, this is the plus q distributed and minus q is placed at the center, okay, minus q. Now this is the interesting. This is the ring and minus q is placed at the center. What will happen? Again the net force will be 0 at the center. At O, F net again will be 0. Force experienced by the small charge q due to this ring will be 0, no doubt. But when we'll disturb this minus q little bit by the very small distance, what will happen? This negative charge and this is the positive. Of course, it will attract. Towards the center, and if we are disturbing in this direction along the x-axis, that is along the I cap, it will move and try to regain due to the attractive force, and it will move towards negative I direction, so it will try to go to the same point. It means this negative charge is in a stable equilibrium. As this charge will move and reach to the center, the force will be how much? 0. Due to inertia, it will move a little bit out of the ring, okay, towards negative, out of the ring. Again, as it will move out of the ring towards the negative, again this ring will attract this negative charge towards its center, and this happens. It goes on and this charge will start oscillating. Again this charge will perform simple harmonic motion, and you will be asked in competition what will be the time period. In a small type of questions, in not very tough level, for easy level, you will be asked whether this system performing simple harmonic motion or not. Whether this system is performing simple harmonic motion or not, you have to only check, okay. So this is very simple. Whenever you will try to check whether this one is performing simple harmonic motion or not, try to keep in your mind, if the particle try to regain its actual position and try to go again at its actual position, then it is in stable equilibrium. Otherwise, it is in unstable equilibrium. Okay, student. So in this way, you can solve such type of question. In detail, I'll discuss in classroom program, students. Okay. Now, students, today's lecture I'll conclude with the question, because I got the mail of 2 or 3 students said you haven't discussed question on vector form of Coulomb's law. Okay, students, so I'm telling here because we are having 5 to 7 minutes in this lecture. Which type of question, or what is the importance of vector form of this Coulomb's law? Okay, student. So while you are solving such type of question, student, this is the square, and you will be asked to find, this is the plus q minus q. You will be asked to find the force on O. This is the distance r. No doubt you can solve this question by the simple method. But how you will apply the vector law of Coulomb's law here? Because after this question, I'll give you another question in which you will compel to solve that question by the vector law only. That to save your time. Otherwise, if you solve by the simple method, it would be very difficult. Even it would be difficult for teacher to solve. So you need to know how to apply the vector form of Coulomb's law. Here with a simple question we are trying to just learn how to apply this law in vector form. Now students, you have to find the force on this charge. You know that all three charges will apply the force, as this charge will be repelled by this one F1, this charge will attract by this one F2, okay, and again it will repel by this one, this is F3. I hope you are able to see. I'm telling this is F3, this is distance R, this is also distance R since it is square. Now how you have to solve this one? So you have to apply the vector law. Vector law tells you F is K Q1 Q2 by RQ and vector R. Okay, here three forces we are having, so the F net will be F1 plus F2 plus F3 in vector form. Are very simple. F1, okay, F1 it is K F1, this one K Q1 Q2, that is Q square, are divided by RQ. What is the distance here? Magnitude is R, so the RQ and the direction in vector form you have to write. Okay, the distance between these two you have to write in vector form. So in vector form it is the vector R. Remember, vector R. Okay, now plus in unit vector also you can write, and that would be very simple. I think we have put here the unit vector if it is RQ. So it is unit vector. This direction I am using as minus R cap. Okay, now plus the second force. Second force is this one. This would be the I cap, so that it would be better for the representation. Now this one again we are having here K Q1 Q2, this is small q, no? This is capital K Q1 Q2 divided by RQ and the unit vector R, unit vector R, that is R, this unit vector R will be the direction. What will be the direction? J cap plus this force, it is F3 K Q square divided by what will be the magnitude of this distance. It is magnitude will be the root 2R, so the root 2R Q, and the direction will be here, the direction of this will be along the direction minus I and minus J. Minus I, you will break the component, this will minus J and minus I. So this 3. Now you will add this 3 in vector form and then you will find the net force. Okay, this will be your answer. Might be you are feeling that, sir, previous method was simple. Okay students, you are correct, that previous was simple, but you will be asked to solve this question. Then what will happen? You will be asked to solve this question. This is a cube. Okay, this is the cube and the charges are placed at the vertices. Okay, equal charge. I'm making a little simple this question. And the cube, this is the cube of side A. Okay, and you have to find the force. Find force at capital Q which is placed a distance from the center of the Q. This charge Q is placed above A from body centered of the cube. Here at point O, cube of side A, find force at Q which is placed at O due to all the charges. Now you can see you will break the component and that would be the very difficult, but using that vector form you can solve this question very easily. Okay, in classroom program I'll just explain you how to solve such type of question. Thank you, students.